ஸ்டார்ட் பண்ணலாமா சார்?
Hello.
சார் ஸ்டார்ட் பண்ணலாம் சார்.
Sir, sir, my mic does not work, sir. Hello. Hello.
சார் இப்போ கேட்குது சார், உங்கள் வாய்ஸ் இப்போ கேட்குது சார்.
அதான் சார். இல்லை சார், நான் ஹெட்ஃபோன் போட்டிருக்கேன். அந்த ஹெட்ஃபோனில் கேட்குற மாட்டேங்குது சார். ஒரு நிமிஷம், ஒரே செக்.
ஓகே
ஒன்னே
ஓகே ஓகே.
ஒரே நிமிஷம் சார். ஹலோ சார்.
ஆ இப்போ கேட்குது சார்.
ஓகே சார். ஓகே,
ஸ்டார்ட் பண்ணலாம்.
ஐ வில் ஸ்டார்ட் சார். ஓகே சார்.
ஓகே ஓகே.
குட் மார்னிங் ஸ்டூடெண்ட். நமஸ்காரம். Today we are going to discuss one topic from current electricity. Okay. So class 12th physics, chapter name current electricity, and topic name potentiometer. In this potentiometer, we will see another two type of cases. That is, with the help of this potentiometer, how the EMF of two primary cells are compared. Okay, that is one case. Another case is how the by using potentiometer, okay, how the internal resistance of the given primary cell can be calculated. Okay, there are two cases which is we have to calculate by potentiometer. Okay, right. So first of all, what do you mean by potentiometer? This is a basic question. First of all, we will see the basic definition of potentiometer. Okay, so potentiometer, it is a device which is used for accurate measurement of potential differences current and resistance. Okay, so potentiometer is a device, a very simple device. Okay, so it is a device which is used for the accurate measurement of potential differences, current and resistances. Okay, right. So this device consists of 10-meter long wire like this. Okay, so every single line, which is means 1 meter wire. Okay, so 10 line. Okay, so 10 meters. So okay, 10-meter long wire, long uniform wire. So it consists of 10-meter long uniform wire of which is manganese, or it may be a constant. Okay, it is a type of material. Okay, so it may be made up of manganese or constant, stretched in a parallel rows. Okay, each of 1 meter. Already I told you that is each of 1 meter. This is 1 meter, this is 1 meter. So 2 meter, 3 meter, 4 meter, 5 meter, finally 10 meter. So 10 meter wire is stretched on that wooden board. Okay. So parallel rows of each of 1 meter length wire on a wooden board. Okay. There are two ends, one end here and one end here. This is a free ends. Okay, maybe it may be called as known as a comma b or p comma q, whatever. Okay, whatever symbol we can use it in that side. But that end means which is the free ends of this structure. Okay. Okay. So for a meter scale, which is meter scale, which is used to find the length of already we will see later, that is balance in length. Okay, so meter scale which is used to find that length. Okay, so that meter scale fixed here, that meter scale fixed parallel to this wire, and another one device, that is jockey used. The jockey is provided for making contact. That jockey sliding over this wire, and then we have to see that deflection in the galvanometer. Whenever galvanometer deflects zero deflection, and note that reading by using this scale, and note that reading maybe 755 centimeter or 829 centimeter, whatever else. Okay. So this is a basic process. So a steady current maintained across battery. Okay. So the symbol diagram of potentiometer like this. Symbol diagram. Okay. There is a battery. So battery has a EMF. So this is EMF. Okay. Battery has EMF, and then galvanometer. So which is denoted as D and G, and high resistance, because that jockey has very sensitive material. Okay, so it does not absorb a huge amount of current. So we have to include high resistance here, and then connected to the J mean jockey. So which is sliding over that wire. Here one battery and key and connector. This is a basic diagram for potentiometer. There is a two end. So here one end A, here one end B. So this is battery, this is EMF, this is key. So this is known as key. Key is which is used to close the circuit or open the circuit. Suppose key closed, current passing through that circuit. Suppose key opened, current does not circulate on that loop. Okay, right. So suppose jockey is over here and the galvanometer shows zero deflection. Then we have to calculate the distance between this position to this position by using scale is here. Okay. So we have to calculate length between this position to this position, because in this position galvanometer shows zero deflection. Okay. So the battery, key, and this is potentiometer wire, and EMF and the galvanometer high resistance are connected like this. The positive terminal of the primary cell of E is connected to the A point. Okay, this is positive, which is connected to the A point, and the negative terminal of that EMF connected to the galvanometer, and that other terminal of the galvanometer connected to the high resistance, and other terminal of the high resistance connected to the jockey. Like that, this circuit, okay? So positive terminal of the battery is connected to the A, and the negative terminal of the battery connected to the key, and the key, other terminal of the key connected to the other end, other free end, that is B. So let the contact be made at any point by J, that is jockey on the wire. Okay. So suppose this jockey here and galvanometer shows 0 diffraction, and we have to measure this length. And what is the use of this length, sir? What is the use? Why we need to measure length here? Because the length difference between this point to this point, which is equal to potential difference, that is equal to EMF of this cell. Okay, the potential difference across this point to this point, which is equal to EMF of this cell, and there is no current flow through the galvanometer. That's why galvanometer shows a 0 deflection. Once balance that EMF of the cell on the wire, that is potential difference, galvanometer shows 0 deflection because of no current flowing through this galvanometer. Okay, so that's why it shows a 0 deflection, and that length is called balancing length. So here AJ is the balancing length. So balance length, which is denoted as L. Okay, so the potential difference across A and J, which is equal to EMF. Already I told you. So that EMF, which is equal to IRL. Okay, IRL. I means current flowing through this circuit. R means internal resistance of this cell. L means that length, balance length. Now you make clear with that IRL. Okay, I is the current flowing through the cell, through the wire. R is the resistance. L be the balancing length. Okay, right. So this is a basic definition for potentiometer. Okay, now we can move into that another case, that is comparison of EMF of two cells using potentiometer. By potentiometer, now we are going to compare the EMF of any two cell. It may be Leclan cell, Daniel cell. Okay, any two Leclan cell, any two Daniel cell. Okay, for clarify, we have to compare one Daniel cell with a Leclan cell. Okay, right. So to compare the EMF of the two cell, we have to made one circuit like that. So here A, here B. Already you know that. Here battery, here key. Now introduce a one apparatus, that is rheostat. Rheostat, which is used to change the resistance across the circuit. Yeah, rheostat. Okay. And then here take that single EMF replaced with that 2 EMF. That is 2 cell. That is E1, E2. EMF of the first cell, EMF of the second cell. So, which is connected to like that. And as usual, galvanometer, high resistance. And then Jackie. So, this is a circuit diagram for comparison of EMF of 2 cells. So, here there are 2 cells. So, that's why there are 2 EMF. But at any time, there is a one EMF, that is one cell connected to the circuit, other cell does not connect. And second time, another cell connected to the circuit and first previous cell does not connect. How, sir? How the connection we can make one circuit, one EMF off and another another cell is on, and the second time previous off cell now on. Okay, by using two-way key. That device is called two-way key. Okay, two-way key. That is DPT switch. DPT switch. DPT means double pole, double throw. In your upper lab, physics lab, you can see that DPT switch. Okay. So by using DPT switch, you can connect one cell to the circuit and another cell off. And one cell connected to the circuit, another EMF off by using DPT switch. So here DPT switch, that is another name, two-way key. Two-way. Two-way. So one way, second way. So here you can select, you can stand here and you can select this one path or this one path. Suppose you choose this path does not include. Suppose you choose this path does not connect. So that's why it name as a two-way key. Okay, right. So potentiometer wire, that is AB, is connected to the battery and the key and the rheostat. This is a primary circuit. Primary means that is a very important circuit. That is primary circuit and the first circuit. Okay. And second terminal of the A terminal connected to the DPT switch. In this DPT switch, that two cells are connected. Okay. So after that, the other end of that DPT switch connected to the galvanometer and other terminal of the galvanometer connected to the high resistance and other terminal of that high resistance which is connected to the Jackie. Okay. So here the bottom circuit is known as secondary circuit. Okay. The cells whose EMF E1, E2 are compared or connected to the terminals here. Okay. So these cells to be compared. These two EMF to be compared. So 2 EMF means 2 cell. Okay. Because every cell has a EMF. Okay. So once a DPT switch pressed, one cell is included in the secondary circuit. So once DPT switch pressed, okay, one EMF, that is E1, connected for the first time. Now we have to find balance length. we have to find balancing length. That length, which is denoted as L1, okay? That length denoted as L1 or L1, okay? Any format is okay. So, which is found by adjusting the jacky over the wire to make zero diffraction in the galvanometer. Okay. Then second, the next step, once the DB switch pressed, now E2 is connected for the second time. Okay. By using the DBT switch, we can choose which is cell to be connected and which is cell to be disconnected. Okay. So E2 now connected. That is EMF2 is included in the secondary circuit. Now again the same process, balance length L2 or L2 found by using jacky sliding over that wire. And that wire has a resistance. Yeah, that resistance is denoted as, already I told you, that is small r. Yeah, resistance per unit length of the potentiometer wire. And I be the current flowing through the wire. Okay. So, for the first cell, that is E1, potentiometer equation, that is EMF, which is become as, already we know that E is equal to IRL. For the first cell, E1 is equal to I, that is same current, or same wire, so same resistance. So, but L1. For the second cell, EMF, which is I or L2, same current, same wire, so same resistance, but balance length will change. Now you can divide. This is a equation 1, this is a equation 2. Now you can divide this equation. So E1 by E2. So you can cancel that common terms. I, R, R. So L1 by L2 is final. So by comparing that EMF of these two cells, what terms will arrive? That is L1 by L2. That is, it depends on length, balancing length. Okay. And you can change the rheostat in the primary circuit, and the experiment can be repeated several times by changing the current flowing through it. Okay. You can adjust the rheostat, which is denoted as RH. You can adjust the rheostat in the primary circuit. The experiment can be repeated several times by changing the current flowing through it. Because in the first step, I means for example 10 ampere. For the second process, for the second experiment, you may choose I2, I is equal to 52 milliampere. Okay, so like that, you can change the current and you can repeat that experiment. Okay, this is how we compare the EMF of the two cell using potentiometer. Without potentiometer, there will be a other method, but by using this potentiometer, we can compare the EMF of these two cells. Okay, so potentiometer is a device which is used to measure accurate potential difference, resistance, and current. Okay, so potentiometer consists of 10-meter long wire, that is, which is made up of manganese or constant. Okay, right, which is placed on the wooden board. I will show you one simulation. Okay, so between that A and B, that is free end, and the jockey sliding over that wire to find the balancing length. Okay, right? So what is the principle behind the potentiometer? E is directly proportional to L. That is, I already told you, that is E is equal to IRL. E equal to IRL. So current same, that is constant. Resistance same wire constant, but L will change. So E is directly proportional to L, means that is, this is the principle behind the potentiometer. Length increases, EMF increases. Yeah, length increases, EMF length decreases, EMF decreases. Okay, right. So now we can move into that simulation. I will show you a simulation for this comparison of two EMF. Once again. Now you may see that one simulation, that is potentiometer comparison of EMF. Yeah. Okay. So this is diagram. I will show you a diagram. This is the diagram. A means ammeter, which is used to measure the current. K1 means key. Yeah, there are two keys. So K1 is there, and another key is a two-way key, DPT switch. E means EMF. Okay, E1, E2. That is two cells. Rheostat and high resistance HR, G galvanometer and jockey. Clear? Okay, right. First of all, we have to choose primary. What is the primary cell and what is the secondary cell? Okay, so in our case, we can change that, which is maybe Leclerc cell may be a primary cell, or secondary cell may be a Daniel cell. Okay, so but in our case, I will choose that is primary is Leclerc cell, secondary cell is Daniel cell. Okay, you can change also. You can change like that. This is Daniel cell. This is the class. By changing the color, you can clarify with that. Okay, if brown color is there, that is Daniel cell. If white color is there, that is Leclerc cell. Okay, so primary cell, I choosing that Daniel cell. Okay, okay, right. So for the second primary cell is Leclerc cell. That is in a white color. Okay, now you have to connect that all the wires, which is circuits. So first of all, that is digital meter 000, which is means the reading of the digital meter. So one end is connected to this key. So this is a key, and that name is one-way key. So there is one way, only one way. Okay. Suppose that way stops, current will stop. Suppose that one-way key closed, current will flow. Okay, that is one option. Either passing through the circuit or stop the through the circuit. Okay, right. So next, this wire taken into the here. So this is battery. You can see the huge box of black color, which is battery. Okay, right. Now from that digital meter, there is a red terminal. So that is another terminal. So take that wire from red color, that is other terminal, to this device. So this device is known as the rheostat. You can see that rheostat. So rheostat, which is used to change the resistance. Okay. So rheostat unit is ohm. So that means you can change the resistance of 5 ohm, 10 ohm, 8 ohm. Okay. So from the top of that rheostat, take the wire and connect into the one free end of this potentiometer. So now in the center, you can see that brown color board, that is wooden board. On that board, there will be there is a wire. Yeah, that is potentiometer wire, 10-meter long wire. Already I told you. There is a scale, meter scale fixed on that parallel to this wires because of to measure the balancing length. Yeah, correct. Okay. Now from the battery, I will take one wire, that's a red wire, connected to the potentiometer free end. Okay, right. And take the one wire from the cell, that is Daniel cell. Take the one wire. So which is black wire. So black wire connected to the two-way key terminal. Okay, right. Suppose you choose by in simulation. Suppose you click, there is a red wire. That red wire should be connected to this terminal, this potentiometer terminal. Okay. Suppose red color is there, you have to connect that red color wire into that potentiometer wooden board. Suppose black color is there, so black color will be connected to that two-way key, that is TBT switch one terminal. Okay. So now Leclerc cell 2, that is a second primer cell. Take the wire. This is black wire. So black wire should be connected to the one terminal to the terminal of the DPT switch. Okay. So okay, correct. So once you place that correct wire, that circuit is same. Suppose you doing that wrong connection, that circuit does not show you. Okay. All right. So in from that Leclerc cell, take that red color wire and connect it to this terminal. Okay, correct. Now this is a galvanometer, digital galvanometer. There is a two terminal in the galvanometer. Take that one terminal. This is black, which is should be connected to the jacky. So here you can see the jacky. Okay, jacky is which is used to sliding over the potentiometer wire. Yeah, clear that? Okay, right. So now from the galvanometer, take the wire and connect it to the high resistance. Yeah, connect. Correct. From the high resistance, take the black wire from to this two-way key DPT. Okay, right. Now circuit is correct and ready. So that's why it shows that insert key. Right. This is the circuit. You can see that. Okay. Now insert one-way key. I will insert one-way key here. Okay. So you can see that ammeter reading. There is a value 0.051, which is a digital ammeter reading. Where is a ammeter reading? Ampere. Okay. You can change the rheostat value. Okay. You can change the rheostat value. In this case, ammeter reading also changes because resistance changes. Resistance changes, so current decreases. You can see that. Yeah. By using rheostat, you can choose the what is the ammeter reading. So for first case, take the 0.051. For the second case, increase the rheostat resistance and take that ammeter reading is 0.049. Okay, so that's why rheostat use it. So okay, this is the second step. Third step, insert the two-way key here. So in this two-way, you can see that there is two hole. So one hole, you insert that key to in one hole. That cell will connect. In another hole, you insert that key. That cell connected. Okay, right? So you can remember that two-way key. Now I insert the key here, one hole or one hole. Now you can see that, yeah, that hole changes. Okay. Okay, so now to check whether the connection are correct or not, place the jockey on two end. So in one end, you can see that in digital ammeter, digital calorimeter 30. In one way, in another end, which is minus 30. So correct, connection correct. There is a maximum and minimum reading. That is a maximum deflection, minimum deflection. So maximum deflection 30. You can see that. And for that another end, another free end, in that end, you can see that minus 30. Yeah. So opposite deflection. Plus 30 to minus 30, which is, you can see that you can remember that, which is opposite direction. Yeah. So galvanometer shows the opposite deflection for that two end. Yeah. Which is different to each other. So correction are correct. Suppose in both end it shows 30-30 or minus 30-30, correction wrong. So then you have to interchange any circuit, any wire. You can replace that wire. Okay. So in our real life physical laboratory, there are lot of error will happen. Yeah. So in that case, you have to consider that is the sensitivity of that all the devices, current fluctuation, wires. So you have to consider all the errors in that in real life physics lab. Okay. So connection now correct. If the galvanometer shows opposite deflection, the connection are correct. Yeah, right. Slide over that jacky over the potentiometer wire. Okay. So you don't see that 10.1, 10.1. This is a length, but you have to see in that galvanometer that is 30. That 30 will become a 0. So in one place. Okay. So here also 30, 30, 30, 30. Okay. Here also 30, 30, 30. Now in that place. That place you have to, okay. So 30 decreases. Now you can see that, yeah, yes, 11, 9, 10, 6, 3, 2, 0. Yes, galvanometer shows 0 deflection at the reading of 770.5 centimeter. Okay, so 770.5 centimeter. So note that reading. Note that reading. Okay, right. Correct. Now galvanometer shows a 0 deflection and measure the length. So this is the balancing length. Now you can see that is 770.5. This is the balancing length L1. Record that value. So for that for that uh, for that you can tabulate that reading. So for that ammeter reading now, so 40 milliampere. Okay. Balance length now we have 770 centimeter in centimeter. For the balance length L2, you have to include another cell. Okay. So record the values in the table column. First of all, E1, that is E1 calculated for L1 for that ammeter reading. Now take that insert key and put it down on the other hole. That is on the other way. Now you can take that jacky and sliding over that jacky over that wire. You can also see that so 30, 30, yeah, 30 decreases. Yes. So 555. So for valence length, 555. So now you can see that reading, meter reading 40. So this is for example, okay? You don't take that value into the real life experiment. This is for example. That value will change, should change. Okay. So for ammeter reading 40, balance length for that, for the primary cell, which is Daniel cell. Okay. For balancing length, for the Daniel cell, 770. Balance length for the Leclan cell, which is the second primary cell. So balance length 555 because EMF will change. So balance length will also change. So 775, 55, and ratio of, so E1 by E2, 0.72. This is a first process. Repeat the process for the, it may be 4 or 5 values. Okay. So for second reading, you can take for that, you can change the rheostat and, sorry, you can change that ammeter reading for 0.48. Okay, so that is milliampere. In that case, balance length will also change. So for example, so here 8 6 and balance length for Daniel 5 8 means, so ratio to that 0.75. Okay. So adjust the rheostat, change the ammeter reading, insert the key K2 for the Leclan cell or Daniel cell, make the reading, make the find that balance length and make the reading on the Doppler column. Find the ratio between E1 and E2. Okay, so you can take 4 or 5 values, and finally you have to compare, you have to calculate the mean values. So already you know that is of 0.72. This is the first value, first reading. 0.75 is the second reading, and for that all the case which is belongs to which is nearly 0.72, 0.75, 0.74. So finally, which is mean for this reading 0.7475. Okay, so this is a comparison of better EMF of this two cell, Daniel cell, Leclan cell. Okay, now you may clear with that circuit, and so this is a symbol, and like that for like reading it is not correct, which is used to uh, like how to say that that reading does not same for your real physics lab. Okay, so you have to consider. Don't take that value. Okay, right. So this is first case, and now we can move into the second case, that is by using potentiometer internal resistance of the cell to be calculated. So that same diagram, but in that internal resistance, there is a only one cell. Okay, for internal cell, because for internal cell you have to put only one cell. So same principle. Potentiometer is a device which is used to measure the potential difference, current, resistance. Construction also same. Principle also same. Principles means U is directly proportional to L. Okay. For determining the internal resistance of the cell, internal resistance of the cell, circuits like that. A, B, So galvanometer, okay, and high resistance and checking. So here also one battery, key, rheostat. This is a basic diagram for measurement of internal resistance of the cell. Clear? But in this circuit, another one important device which is should be connected, that is resistance. That is external resistance. That is main resistance box. So here, so which is very important for this device. So for this case, another key should be connected. So this is K1, this is K2, key 1, key 2. Okay. This is battery, this is key. You don't need to connect the rheostat here. Okay. So because rheostat does not use in this scenario. And the EMF galvanometer high resistance, for that EMF parallel, there will be a one resistance box R. Okay. For this, K2 should be connected. To measure the internal resistance of the cell, circuit connection are made shown in the figure. Okay. Clear? The end of the A, which is connected to the, okay, right. A, which is connected to the positive terminal of the battery, and negative terminal of the battery is connected to the key. That other terminal of the key connected to the B. So the other terminal of A connected to the EMF, and again galvanometer high resistance through the Jackie. So there is a resistance box which is connected parallel to the EMF of the cell. Okay, again also one key is there. Clear? Right. So now also the same case. Now also the same case. Like the positive terminal of the cell, okay, positive terminal of cell, which is has a EMF E, whose internal resistance to be determined. Okay, so that EMF is connected, whose internal resistance should be determined in this circuit. Okay. The negative terminal of this cell is connected to the Jackie through this galvanometer and high resistance. Resistance box, this is connected here and connected, and there is a key connected here. Okay. So when K2 open, K2 open means this circuit does not include it because K2 open. Okay. With K2 open, balancing length to be determined. That balance length, which is denoted as L1, because this circuit does not include, you can do the same process. Connection made and Jackie over the slide, over that wire, and shows the galvanometer zero deflection. And at that time, note that length, which is L1, balancing length. Okay. So E is directly proportional to L1. E is directly proportional to L1. Now, suitable resistance, it may be 5 ohm, 10 ohm, or okay, in any other resistance. A suitable resistance, say 5 ohm, is included in the resistance box here. Included. Okay, so this is 5 ohm or 6 ohm, whatever. So key K2 closed. K2 closed. So closed means this circuit will now include in that circuits. So current passing through these circuits. So that's why I'm saying that this circuit included in the circuits. Okay. Right. So K2 is closed. Now, so R be the internal resistance of this cell. R be the internal resistance of the cell. Current passing through that cell and resistance box also. Current, because current is flowing through this circuit and passing through here and passing through also. So current flowing through that cell and the resistance box. R be the small internal resistance of the cell. Okay. Then next, we know that for that two cells, okay, so E is directly to L1. And again, current is passing through that resistance box. So that terminal, which is voltage called as denoted as V. So which is directly proportional to L2. Now you can divide both these equation. So E by V. So L1 by L2. Yeah, clear? Okay. But we know that E, that is EMF, which is I into, so EMF or voltage, which is known as current into resistance. Yeah, current into resistance. So V is equal to IR. You know that from Ohm's law. V means potential difference. E means also EMF. So EMF also potential difference. Okay. So EMF, which is current into resistance. But EMF has another one resistance, that is internal resistance. So we should add small r here like this. Okay. So E is equal to I into R plus R. Clear? Right. And V is equal to IR by Ohm's law. So from for E, I into R plus R. For V, IR, which is equal to L1 by L2. You can cancel II because same current passing through this circuit. So cancel I into I. R plus R by R is equal to L1 by L2. And this R belongs to both these equation, both these term. R by R plus R by R is equal to L1 by L2. Yeah. So R by R cancel 1. So 1 plus R by small r by capital R equal to L1 by L2. Next step. Okay. So I can write it here now. So 1 plus R plus R, which is equal to L1 by L2. Yeah, correct. So that 1 goes here. So it becomes as minus. So R by R, which is equal to L1 by L2 minus 1. Yeah. So R, this R goes here. So R into L1 by L2 minus 1. Clear? So this is a step which is used to find the internal resistance because R is here. R means internal resistance of that cell. So which is depends on capital R, that is resistance box resistance. Okay, L1. Before the introducing the resistance box, balance length L1 and L2. After introducing that resistance box, balance length L2. So this is the equation for internal resistance R of the cell to be calculated, to be determined. Okay, using this formula, internal resistance R of the cell can be calculated. Now you can clear with that. Okay. So small r is equal to capital R into L by L2 minus 1. Substituting that values of R, it may be 5 ohm, 6 ohm. Okay. L1, already you have balance length L1, L2. So internal energy, internal resistance of the cell is determined. The experiment can be repeated for different values of R. Okay. you can change that R value for 5 ohm, 6 ohm, 7 ohm. So you can change the capital R value, that is resistance box value. The experiment, which is can be repeated for different values of R, it is found that internal resistance of the cell is not constant, okay, but increases the increase of external resistance. So that means R is directly proportional to R. Okay, so this is a we can now just sub change by this symbol. R is directly proportional to R because both are directly proportional. So which is means resistance increases, internal resistance also increases. It is found that internal resistance of the cell is not constant but increases with the increase of external resistance connected across its terminal. So this is by internal resistance of the cell to be calculated by using potentiometer. So both are questions, are 8-mark question. Okay. So this is one important question. Now you can ask any doubt regarding that potentiometer internal resistance comparison of 2 EMF, or otherwise I will ask doubt for particular student or particular ID. So please unmute Oppo Reno 2F. You can unmute and ask me any doubts regarding this topic. Oppo Reno 2F or KGPV, Litula or TKC, GJG, Palaminar. Please unmute and you can ask a doubt. So potentiometer this is the device used to measure the accurate measurement of potential difference, current, resistance. Yeah. So comparison of EMF of two cells, we take that two cell, that is Daniel cell, Leclerc cell. Daniel cell has one EMF, that is E1, and Leclerc cell another EMF, that is E2. By using that circuits by simulation, we can see that by comparing that EMF E1 by E2, which is equal to L1 by L. That's length increases, EMF also increases. Okay. Then next case, internal resistance of the cell. So in this case, we can replace that two cell by one cell, because in this case, only one cell is enough for to be, because that cell internal resistance to be determined. Yeah. But in that case, there is a resistance box which is connected across the EMF. Yeah. So that resistance, which is very important, because internal resistance depends on that external resistance. Suppose external resistance increases, internal resistance of that cell also increases. Yeah, clear? Okay. So, for this equation, we can remember the Ohm's law. V is equal to IR and E is equal to R into I plus R. Okay. From that, we can derive that internal resistance of the cell. R is equal to capital R into L1 by L2 S1. Okay. This is over. Okay. Thank you. I will finish my class today. For next class, we will see another one important question. Okay. Anybody has doubt, please unmute and ask me doubts. And please go through your book and compare with that class and make it notes and recall it that concept and write it down. Okay. So you can write it down 4 or 5 times. That's why that concept will be clear. Okay. Thank you. Jai Bharat, Jai Hind, Jai Vidya. Thank you.
தேங்க்யூ சார்.